All right, so there's three possibilities, three possible ways to do a KSP. All right? Way number one, we take some, say, calcium hydroxide, and we throw it in water. All right? We throw enough calcium hydroxide in water that some of it precipitates. Then you're asked, what's the concentration of, say, calcium, 2+, or the concentration of hydroxide in the solution? So we're going to take the KSP of calcium hydroxide, and how would we write that KSP? Calcium hydroxide is concentration of, everybody? Calcium.
2 hydroxide.
Concentration hydroxide. Squared. Yep. Okay. So, if the concentration of calcium is X, the concentration of hydroxide is 2X. Because we threw one of those in and it splits up into 1 calcium, 2 hydroxide. Make sense? So this ratio holds because that's the way they came in. Example being, if I said, okay, I have couples coming into the dance. The only way you're allowed into the dance is if you're a couple. Yes, it's the same stupid example. Yes?
So for the equation that you wrote, is it not 2OH minus squared?
Nope. It's just the concentration of OH minuses. The reason the squared is there is because, what did you write? You wrote calcium 2+ plus 2 OHs. Just like we've been doing all along, we put the 2 there because there are 2 of them in the equation. All right? So if it's boys and girls come into the dance, what's going to be the ratio of free boys to free girls? 1 to 1. If, on the other hand, we do the Beach Boys thing, 2 girls for every boy, right? It's a song. It's old. It was before I was born. All right? What's going to be the ratio? Yeah, really freaking old. All right? What's the ratio? Boys to 2 girls, right? So it'd be a 1 to 2 ratio. Make sense? Now, because they come in these packages, that's how they're going to be. That should be the absolute ratio. Second possibility. All right? Second possibility. I say, all right, I want to put some calcium ions and some hydroxide ions from 2 distinct sources. I know this is review, just bear with me. All right? Now, the KSP for calcium hydroxide, has the expression changed? No. Has the expression changed? Not at all. Okay? Because it's still the same solubility product for the same material. But now, these 2 are distinct one from the other. Now, what's the toughest way I could throw you at this? Somebody look up the calcium hydroxide's KSP, would you? All right, toughest way I could throw this at you. I could say, okay, I've got a 0.003 molar solution and I throw in 20 mils.
6.5 times 10 to the negative.
Again?
6.5 times 10 to the negative 6.
Yes.
6.5 times 10 to the negative 6?
Six.
Okay. Now, and then over here with the hydroxide, I can tell you I've got a 0.004 molar and I use 30 mils. And I pour them together. Okay? That's about as hard as I can make it. So, what's the moles? I'm going to use millimoles. What's the millimoles here?
I can't read it. What is it?
Sorry.
No, you're fine. It's just far.
20 mils.
It should be
Okay, 0.06 millimoles. And how about this one? 0.012 millimoles. Right? Is that okay? What's the volume in which they're contained?
50 mils.
50 mils. True?
Wait, so why do you do the volume a second time?
Okay, because the volumes change. Because this is a container I threw in, and this is a container I threw in. This had calcium with some spectator. This had hydroxide with some spectator. Is there a typo?
Yeah, I was wrong, it's 0.12 in seconds.
Thanks.
All right. Now, so I mixed the two together, and notice the volumes were 20 and 30, so now the volume's 50. So it dilutes both of them. All right. Now, we plug that into the KSP. 0.06 divided by 50. Notice milliliters, millimoles, so it becomes molarity. 0.12 divided by 50, quantity squared. Now notice there again, these two aren't exact, they are. Damn it. Change this. Okay, I'm just gonna change something so it doesn't work out. All right, so this is 0.01, so this would be what, 0.03 millimoles, right?
Yes.
So that's 0.03. I didn't want them to be exactly 1 to 2 because that would mess people up. All right, so what is this? 0.06 over 50 is
0.0012.
0.0012, and this one is 0.0015. No? No. Just do them. I don't want to guess.
0.0006.
Okay. Squared. True. And so what's that work out to be? It's a whole lot of zeros. Give it to me in scientific. Yeah, please.
4.32 times 10 to the negative 10.
10 to the negative 10. Okay, now, this is a KSP, right? This is a Q. Now, if you've zoned out, zone in. This is a Q. This is, I mix some calcium with some hydroxide. I want to know, does it precipitate? So I go through the math and I say, okay, Q is equal to 4.3 times 10 to the negative 10. Is that bigger or smaller than KSP?
Smaller.
Smaller. So Q is less than K. Therefore, we're going to shift which way? Toward the products, right? Because K and Q are both products over reactants, right? So K or Q is products over reactants. So if Q is too small, we don't have enough product. So according to the way we write the equation, what's products? The ions. So if any solid forms, it's going to shift back over to try to fill in the products that we don't have. So this one, if I mix those two solutions together, the container would have no solids.
So it would not precipitate.
So it would not precipitate because it's not as big as K.
But if it's as big or bigger than K, it will precipitate?
Perfect. So in other words, if Q is greater than or equal to K, we get a precipitate. All right, so those are two of the three ways that I can throw this at you. Could you